Here we go.
Here we go.
Multiplying and dividing polynomials by a constant. Before we go any further, I need to remind you what a constant is. What is a constant?
A number that repeats.
No. It is a number by itself. Okay? Now, first thing I'm going to talk about is the distributive property. Okay? The distributive property is very simply repeated multiplication. Now, every teacher has a fun little nickname for the distributive property. So do I. The distributive property. Because that's what it's called. If you were to do this math, what would you do if I asked you for the answer to that question? Think back to the first unit. Bedmass, of course. And where would you start? Brackets. Are they Bedmassy brackets? How do you know? Because there's an operation in them. So this becomes 5 times 24, correct? Which, when you do that on your calculator, is of course 120. Gouda? Great. Now, what math was happening right there? Multiply. So you know, reading this, that you are doing 5 times 20 at some point, aren't you? Okay. Well, here's 5 times 20. What? That's a rectangle, Mr. Myers. If you cut this into 5, that's not fifths, dummy head. That's better. There's 5, correct? And you do that 20 times, what do you have here? 100, right? And then you do the same thing, cut that into 5, and do that 4 times, you get what? 20. And then 100 plus 20 will get you 120. And you see how you have the exact same answer, yes? So, this diagram uses a picture to show what I am about to show you. First, we write it out. That is a constant. That is a binomial, but it's made up of constants, isn't it? Cool? Okay. So this diagram, the first thing we did was 5 times 20, yes? So we do 5 times 20. And then we did what? No. 5 times 4. Which got us 100 plus 20, which got us 120. Everybody cool? What this is the distributive property of multiplication. And what it means is, if you start with something outside of brackets, and you multiply it by anything inside the brackets, the x, or the coefficient, multiplies to everything inside. So I get x times y plus x times z. And that can go on for as long as this polynomial is. Okay? A great many of your teachers will call this something fun like flying arrows or various other little nicknames, which is wonderful until you get to university. And you say to your professor, "Is that flying arrows, Dr. Smartmathikoff?" And he says, "What?" Okay? Distributive property. That's what it's called. It gets used a lot. As a matter of fact, we've already used it this year. When? Dylan. It's in exponents. Remember? 3 times 7 all squared was 3 squared times 7 squared. The squared went to everything. It's the exact same thing as that. Now, this is no different. Okay? If there was no x there, and I asked you to draw 2 times 4, what would you do?
Draw 2 times 4.
You would draw 2 little guys, because that's 2. How many times?
2 times. No, 4 times.
4 times. Excellent. Well, now I'm asking you to do that with 4x. So you would draw 4x. How many times? 4 times. Twice. And that makes a rectangle. How wide or long is this side? 1, 2. 2. How long is this side? 4 whats? Right. 4x. And what's our answer, which lives in the middle? 8x. So you guys now know 2 times 4x is, the 2 goes everywhere, 8x.
Isn't x basically just 1?
No. X is x. You have no idea what x is. Okay? Gouda?
Great.
Great. Let's go on to this one. So, we're going to use algebra tiles. Alright? So, what do we draw? Algebra tiles for what? For the 3 or for the 2b squared minus 2b plus 1? Right, because this trinomial is being multiplied by 3. Which parts of that trinomial? All of them. So if I start with 2b squared, how many 2b squareds is that? That's 2 2b squareds?
6. Oh, 8.
No. How many is that? That is 2b squareds. How many groups of that do I need? 3. So I draw it 3 times. Then I got to draw negative 2b. How many of them do I need? 3 of them. There's 1, 2, 3. Then I got to draw 1. How many of them are there? 3. There's 1 of them. 2, 3. So what's my answer? 6b squared minus 6b plus 3. Easy peasy lemon squeezy, right? Great. You do these 2. Oh, crap on a bun. No, I am recording it. No, I didn't.
Crap on a bottle.
We're going to fire you like Barney.
Okay. Darn. You fire me. What am I going to be forced to do? Teach teenagers?
No.
That'd be horrible. Be locked in a room with a bunch of people that don't do what they're asked to do? Oh, wait a minute. It's exactly what I'm doing right now.
You mean I'm doing what I'm supposed to do?
No, you're not. You're shaking around a bottle that is disturbingly pink in the water. Not entirely sure why. What you're supposed to be doing is writing.
I was.
No. I've been watching you the entire time I've been talking. You've been shaking water, which kind of surprises me. Although not really, because, you know, a lot of people get distracted by shiny things. So, I have 4 p's and I have negative 3 p's. But I need to have how many of them? I need to do that how many times? thrice. So there's once, twice, thrice. Once, twice, thrice. And what do I get? 12p minus 9. And I do the same thing over here. There's my s squareds, but I don't need one group of s squareds. S squareds, I need 2. So I draw it again. No, for the billionth time. I'm going to say it slower for the people that have trouble with this. When I ask you to, you have to draw it out. 1s, but I don't need 1, I need 2. 3, but I don't need 3, I need 2 groups of 3, which gets me negative 2s squared plus 2s plus 6. Now, I don't want to use algebra tiles again. I want to do this properly. Now, the reason I show you algebra tiles is proven by your last quiz. By not understanding algebra tiles, over half of you also couldn't subtract polynomials. So maybe you should pay attention to algebra tiles, because some of you seem to need them. Since we have now proven how the distributive property works, we can now use it. If we were algebra tiling these, I would draw 4 big E's, right? And then I would do 5 of them, right?
Yep.
Okay. But I don't need to do that anymore because I paid attention the first time. All I have to do is multiply each term by negative 5. Now, here's what I'm going to suggest. Most of you won't do it, and then I'm going to make another list of people that can't multiply either because they didn't pay attention to how to do this. Step 1, always rewrite the problem. Just do that. It takes 2 seconds. Negative 5, 4e squared minus 5e plus 3. Now, if I was doing last lesson and there was a negative in front of brackets, what would it do to all the signs in there? No. Change it. So, if it happens once in math, does it happen every time? Yes. So there's a negative out in front here, isn't there? So that means all of these are going to change. Now, when it was just a negative, did we change the numbers? No. But this time it's a negative with a number. So I have to multiply. What is 5 times 4? 20. But since there's a negative out in front, it has to change. And it is e squared. Draw an arrow, write an answer, and you cannot possibly do it wrong. Most of you won't bother showing me work. You'll write the answer at the bottom. It'll be wrong. It'll be out of 3. I'll give you 0 out of 3 because you didn't show me any work. Then you take the 5 and you go to the next one. It's negative 5, so the sign is going to change to positive. 5 times 5 is 25 e's. Then you're going to draw an arrow and you're going to do the third one. It's positive, so it changes to minus. 5 times 3 is 15. And you're going to be done. Now, is there any limit to how many arrows you can draw? No. This polynomial can be as long as it needs to be, but the arrows just keep going until the coefficient has hit every term. That's why if you draw an arrow, then write an answer, you can't do it wrong. Understand? Okay. Let's run through it. Remember, rough work on the left, thinking on the right. 3 times 7? 21. 3 times 9, 27. So let's go back over here. The numbers go with numbers. 3 times 7, 21s squared plus 27. And it's done. Okay? Draw an arrow, write an answer. This here is just what you would do. Okay? This I usually do in my head. Or if I'm bad at multiplying or the numbers are big, on my calculator. Okay? What's this one now? What's tricky? It's got a negative in front. So what does that mean? Every sign in the bracket is going to change. So I do 4 times 5. 4 times 5 is, but it's got to change, so it's negative 20. And then we care about the letters. E squared. Then, draw another arrow. 4 times 8, 32. It was negative, so it changes to positive. And the letters don't change. Everybody good? Awesome. Now you do the next two. Go. Now, keep writing, just keep an ear on what I am saying. I am going to just write the answer because some of you are already coming up with your own little shortcuts and your own methods for multiplying. Okay? The answer here is 10d squared plus 15d minus 30. Okay? How you worked it out is your business. Do you have to what? Okay. This one, would anybody like to volunteer it? 42 y squared 56y plus 63. Can everybody multiply? All right. So what is the key to remember when we are doing distributive property? The coefficient out in front has to hit every term in the following polynomial. Right? Easy peasy lemon squeezy. Okay? So let's move on to dividing, because dividing and multiplying are buddies, right? They're opposites of each other. So, if I was going to use algebra to show division, I have negative 8x divided by 2. Well, that makes pretty good sense. I got 8 of these negative guys. 1, 2, 3, 4, 5, 6, 7, 8. How many different ways could I write those? Could I do them in a vertical line? Yeah. Could I do them in like this? 2 sets of 4. That's okay too, yeah? It doesn't matter. As long as I have 8 of them and I break them into 2 equal groups. So what's the answer? Negative 4 what? What do you see there? Negative 4x. Now you guys already know why this works. When we did multiplying, the letters weren't affected by the division, were they? Or by the multiplying. 2 times 4x was 8x. Well, same thing here. Negative 8 divided by 2 was negative 4, and then the letter just comes along for the ride. Because there's no letters that are affecting it. Understand? Yeah?
Yeah.
Okay, turn the page over, and we are only going to do one algebra tile division question. Take your polynomial, draw it, and cut every term into groups of 3. So I need 6 positives. And I need to cut that into 3 groups. How big are those groups? 2 each. And I need 9 negatives. And I got to cut that into groups. How big is it? 3. So I got 3 and that. That's the size that is left over after I've cut up my polynomial. So what's the answer? Two S 3. Done.
How'd you get 2?
I had 6 S's, and I cut them into groups of 2, because I divided them to 3 equal groups. Okay? I also could have done this. 1 group of 2, 2 groups of 2, 3 groups of 2. It wouldn't have mattered. Yes?
What if the question was divided by 2 and
You can't divide 9 by 2, can you? So that type of question, Bryn, is not demonstrable with algebra tiles. But what I'm about to show you will be. Okay? So, everybody got it? Now, Bryn just asked a very good question. Hey, Mr. Myers, you just did 2 examples that worked out perfectly. What if they don't? Absolutely. Because I've already told you. Algebra tiles have limitations, don't they?
Yep.
They are only good for basic understanding. They don't go past squared, and you can't do fractions with them. Right? So once we've got the theory, we can move on to what we're actually going to do. Now, obviously, here I'm asking you to draw them all out again, right? No big deal, but I'm going to show you our trick. 3g squared. Oop, not colored, they're positive. Right? Right? 12 g's. Right? Now, cut them into groups of 3. What math cuts this up? Division. So if I do 3 divided by 3, what do I get? 1 box. If I do 12 into groups of 3, what do I get? 4. So what's my answer? G squared plus 4g. Right like that. Got it? What do I got here? Negative 4 b squareds. And 6 little guys. Cut into what size group? 2. Divide by 2, so what do I get? Negative 2 big guys and 3 little guys. What's the answer? Got it? Now again, Bryn's question applies. These are working out perfectly. What do we do if they don't? Don't worry. I don't leave you in the dark. What's this one going to be? 4 big guys divided by 4 is 1 big guy. 4 bars, negative, divided by 4 is 1 negative bar. 8 little guys divided by 4 is 2 little guys. And your answer becomes s squared minus s plus 2. Any questions?
No.
We're still good, yeah?
Yes.
Okay. 6 big guys shaded divided by 3. What's that? 2 big guys shaded. 9 bars unshaded divided by 3. What's that? 3 bars. 9 little guys shaded divided by 3. 3 little guys. And what do I get? Negative 2t squared plus 3t minus 3. Is everybody good? Okay. Now you should have noticed something else that has always been the case in every example I've done up till now. Can anybody tell me something else that has always been the case? It seems a little weird. First of all, it's always worked out. There's never been a remainder. Bryn saw that. Is there another thing that's never changed?
Simplified.
Right, okay. We are simplifying. You're right. Good. But that's not very weird.
That's not weird, but it's the
There's something that we have done with something up there that we have left out half of the numbers in the universe.
In decimals.
They're all positive.
They're all what?
Positive.
What's all positive?
That's like constants.
All the numbers that we are dividing by. Now that has a proper name, which you probably haven't heard since the 4th grade. It is the divisor. Okay? All of our divisors have been positive up till now, haven't they?
Is it divisor or divisor?
Divisor.
Divisor.
Now, when the divisor is negative, we can use what we already know about division. Right? So, what do we know about division? A positive divided by a negative, or a negative divided by a positive, not a 4, you dummy, equals what? A negative answer, no matter what. Okay? Now, how does that apply if there's brackets? What happens here? Negative, bracket, positive, plus a negative. What happens to all these signs? They change. Why? Because there's a negative out in front and I'm multiplying. What would happen if I had a positive plus a negative and I was dividing by a negative? What would happen to all those signs? They'd change too. You already know that. Math works because it is always the same, even when it looks different. Next thing we need to talk about is why this works. This is 8x divided by 4, correct? What is this really on the top? What is really happening here? Just in the numerator. Right, it's multiplied. This is really 8 times x, isn't it? Okay. But it's not 8. It's 8 divided by 4, right? So what has to go here? 4. And what has to go here? 4. Now you guys are smart kids, correct? This is multiplying fractions, right? So how do we multiply fractions? Check diagonally. Is there any that work? Which one? 8 and 4 work. How many 4 is going to 4? 1. How many 4 is going to 8? 2. Right? Yeah? Okay. And then what happens?
Check vertically.
Check vertically. So what happens there?
2 goes into 4.
It's going to be 1 over 2 with an x. Does that make any sense? No, it doesn't, does it? Makes no sense, right? So, thinking about this like a fraction is okay, except if you try to work it all the way out, yeah? Then it makes no sense. Because what do we already know about 8x divided by 4? If I drew it out as 8 x's, and I cut it into 4, where would those lines have to be? So what's my answer? 2x, right? So doing this is kind of a hassle, isn't it?
Why can't you just do 8 divided by
That's what I'm about to tell you. All you are doing is 8 divided by 4, and then the letter lives on its own. 8 divided by 4 is 2, and then the letter lives on its own. Everybody good? Would it matter if there were 25 letters there?
No.
No. Okay? That deals with the first thing. We've dealt with the negative, we've dealt with this. Now we come to Bryn's question. What if I want 3x divided by 2? That doesn't work, does it? Numbers go with numbers, letters go with letters. So this becomes 3 over 2x. And since you guys don't like fractions, what does that become? 1.5x. Everybody cool?
Yeah.
So, Bryn, to answer your question, you just do the division. All right? Everybody else, when it's a negative, it changes the signs. Everybody cool?
Yeah.
All right, so let's look at the next one. I'm asking you to divide this. All right? What is this really? There's this, correct? Which is negative 9v squared over 3 plus this. What's that? 6 over 3. And then you can just do the math. And I even tell you how to do it down here, right? So the first fraction we had was negative 9v squared divided by 3. What stays together? Numbers stay together. What is negative 9 divided by 3? Negative 3, and then the letters come along. Okay? And 6 over 3 is what? Positive 2. So what's my final answer? Negative 3v squared plus 2. Everybody good? Now, most of you are probably not going to need to split this up like this in the 9th grade, because the numbers, for the most part, are going to work out for you, because we want you guys to get good at this. So here we have 12 and 8. Now, if you do it all the way that I just showed you, okay, so split it up. 12r squared and 8. Well, we don't care about the r squared. He's on his own, but we care about the numbers, don't we? So it's 12 over 4 and 8 over 4. What's 12 divided by 4? 3. Then we bring the number along. 8 divided by 4? 2. Got it? That's it. You split it up.
What's the extra blank for?
I don't even know why I have that many blanks there. I probably could have written one more step, but it's been so long since I've done all these steps that I'm starting to lose them. Split this into 3. What's the first one? 18v squared. What's the second one? No. Negative 6v. What's the next one? Positive 12. Numbers go with numbers, so what goes here? 18, and then the v squared's on its own, because we're not touching the v's, are we? Right? What about here? Negative 6. Numbers go with numbers. Are we touching the v?
No.
Nope. And numbers go with numbers. 12 divided by 6 is 2. 18 divided by 6 is what? 3. Don't touch the number. V squared. Negative 6 divided by 6? Negative 1. Do we write 1? Negative v plus 2. And we're done. Yeah? Great. You guys do the last one. Use as many of those lines as you want. I'm only going to write the answer. Everybody good?
Yes.
All right. Now I'm going to write one more just to make sure. Negative 6v squared plus 8v minus 4 divided by negative 2. What's my answer? Try and do it just for fun without writing it out. Just try to do it in your head.
Without writing it out.
Just try to write the answer right here. Don't do any work. If you need to group, group. Right? Like the first thing you're going to do is this, right? So what's that answer going to be?
3v squared.
3v squared, because two negatives make a positive, and the letter tags along. Now this one. Negative 4, because the numbers stay together, and the letter tags along. And then positive 2. What did you notice that this negative did to all my signs? Positive, negative, positive. Everybody good? Okay. Please notice that I have already cut down a lot of this. Right? It looks long, but it's not, because I've already done some A's and ABCs and such. So 246, I'm just going to double check and make sure that I'm happy with that. You do not have to do 3. I am trusting you on algebra tiles. You do have to do 5A. You do have to do 6. You do not have to do 7. You have to do 9. I like that 11. You're going to do that. You're going to do 13. You're going to do 15 A and B. You're going to do 16 A and B. You're not going to do 18. You're not going to do 20. You are going to do 22. And you are going to do 23. It is 11:36. You have 14 minutes till break. When you get back, I'll give you a couple more minutes with this. Then we will go on to multiplying and dividing by a monomial. We will not get to quizzing today. You've already done 2. That's pretty good.